Hello, pre-calculus students. Let's move on to section 2, which is graphs of equations. Again, this should all be a review. That's why I'm going to fly through it. So here's my x-axis, here's my y-axis. Where the graph crosses the y-axis, we call that the y-intercept. Anywhere the graph crosses the x-axis, we call those x-intercepts. So we're just learning some terminology right now. Let me rephrase. We're reviewing some terminology right now. Now this one is very important, muy importante. These are parent graphs. Parent graphs are the simplest form of a variety of, or a family of graphs. So lines, the simplest form is y equals x. Now, if we maneuvered that a little bit, we could change the slope, we could change the y-intercept, we'd get a different line. But y equals x, goes through the origin, has a slope of 1, is our most basic line. So it's called the parent graph for all other lines. For a parabola, at least a parabola that opens up or down, there's a different graph, a different parent for opening sideways and such. But the most basic parabola is y equals x squared, and it looks like this graph here. A cubic, now you might recall that a cubic can go up, down, up, but in simplest form, a cubic is y equals x cubed, and that's this graph. The absolute value graph, this piece is y equals negative x. This piece here is y equals positive x. And we can just write it as one expression here, the absolute value. And square root. If you square both sides of this, this is x equals y squared, which is kind of, you move the exponent over here, x equals y squared would give us this parabola that opens sideways. But that wouldn't be a function because it wouldn't pass the vertical line test. Nod your heads like you remember the vertical line test for seeing if something's a function. Good. So to make it a function, we say when we do a square root, that's the positive square root. So it's really half of a parabola. I know I'm going fast. Feel free to pause the video to take good notes. There are different types of symmetry. Some graphs don't have any symmetry at all, but some graphs do. So the first type is called x-axis symmetry. In other words, a graph can be reflected, or a graph is reflected over the x-axis. So if a point xy is on the graph, to reflect it over the x-axis, the point negative y would also have to be on the graph. So this was x equals the absolute value of y. You get this equation. This is that parabola that opens sideways, opens to the right. And you can see that every point on the graph, if 9, 3 is on the graph, x is 9, y is 3, then 9, negative 3, because negative 3 quantity squared is also 9. 9, negative 3 is on the graph. So every point xy that is on the graph, x negative y is also on the graph. Thus, this graph has x-axis symmetry. What do you think about this circle, x squared plus y squared equals 9? Does it have x-axis symmetry? And the answer is yes, it does. If for this point right here, which is some x, y, you can go x negative y is also on the graph. You might say, what about here? Well, there's no point out here on the graph. We're only looking at points, xy points on the graph. So a circle has x-axis symmetry, which means it's a mirror of itself over the x-axis. And it also has y-axis symmetry, and it also has symmetry for a mirror image of any line going through the origin. But right now we're just talking x-axis symmetry. What about a line that has y-axis symmetry? In other words, the y-axis forms a mirror, and the graph is a mirror of itself around the y-axis. Well, go back and look at these two graphs. Y equals x squared. Yep, the y-axis goes right down the middle of it, and it's a mirror image on both sides. Same with the absolute value graph. And what happens there is, if xy is on the graph, then to flip it over the y-axis, negative x comma y also has to be on that graph. Symmetry about the origin. If xy is on the graph, then negative x, negative y is on the graph. And y equals, you should be able to see that down here, y equals x, a line with a slope of 1 through the origin. Y equals x cubed. Both of those have origin symmetry because this is true in both. Also, you'll notice that if the point, let's pick y equals x cubed. So the point 2, 8 would be on the graph of y equals x cubed, and negative 2, negative 8. You should be able to take these 2 points, connect them with a line segment, and that line segment will always go through 0, or go through 0, 0, the origin. It's a way to test if something has origin symmetry. On the bottom of page 15 of the current text that we're using, there are some tests you can use for symmetry, for those 3 different types of symmetry. Let's zoom in on that right now. So if something has x-axis symmetry, in other words, it is a mirror image over the x-axis, if you replace y with negative y and you get in the equation, and you get exactly the same equation. We're going to do that in the next slide. For y-axis symmetry, if you replace x with negative x, go back and take a look at those last few slides and you'll see that we actually did this in the pictures. And then for origin symmetry, you replace x with negative x, y with negative y, and you still get the same equation. So let's do that now. Here's a graph that has x-axis symmetry. We can tell by looking. This is the graph, in case my picture was blocking there. X equals the absolute value of y. So y equals the absolute value of x looked like a V. X equals the absolute value of y looks like this, and you can check that. Here's the point 4, 4. So x is 4, y is 4. Here's the point 4, negative 4. X is 4. Its absolute value of negative 4 is 4. So this is x equals the absolute value of y. So if y is negative 4, the absolute value of it would be 4, which is x. So to see if something has x-axis symmetry, it should flip over the x-axis, that changes the y value. So we should replace y with negative y and see if we end up with the same equation. And if we do replace this y with a negative y, the absolute value of negative y is the same as the absolute value of y. So this graph does have x-axis symmetry by doing that substitution. For something to have, let's do y-axis symmetry next. That'll be more fun. Y-axis symmetry, y equals x squared. That's the basic parabola. You know that that has y-axis symmetry, but let's prove that it does by replacing x with negative x, and we should end up with the same equation. Now, this is negative 1 times x. This is a times b to the second power. That's a squared b squared. Well, it does turn out to be the same. So what that does is that shows us that this equation does have y-axis symmetry. Even if we didn't recognize that as a parabola and didn't have a graph to be able to tell visually, we can do this substitution and confirm that it has y-axis symmetry. And we've already pointed out that the graph of y equals x cubed has origin symmetry. It's symmetric about the origin. So we need to replace x with negative x and y with negative y into the original equation and see if we end up with the original equation. So negative y goes in here, negative x goes in here, and we're going to cube it. Well, negative y stays negative y. This becomes negative 1 cubed times x cubed. Well, negative 1 cubed is negative 1. So you have negative y equals negative x cubed. Multiply or divide both sides by negative 1. You get back to the original equation. So we have just demonstrated that y equals x cubed has origin symmetry. Now, we did a circle before. Let's do it again. X squared plus y squared equals 9 is a circle centered at the origin with a radius of, hopefully you said 3. So if we're replacing y with negative y, which symmetry are we checking? Well, if we're taking a y value and moving it down to negative y, or a negative y moving it up to positive y, we're checking x-axis symmetry. So we're going to replace y with negative y. You see we end up with exactly the same equation. So this circle does have x-axis symmetry. The x-axis serves as a mirror, so we can see a mirror image over the x-axis. Okay, let's take a look at this equation for circles, just as a reminder. It's x squared plus y squared equals r squared. That is a circle. It's centered at the origin with a radius of r. So it's x squared plus y squared equals a radius squared. That's why in the last slide, x squared plus y squared equals 9. The radius was 3. So here's a circle centered at hk. So we're going to replace x with x minus h, and that will move every x coordinate h units to the right. We're going to replace y with y minus k. That will move every y coordinate k units up. If k is negative, then that's y minus a negative k. And so if the equation was y plus 5 squared, that's the same as y minus negative 5. That would actually move it 5 units down. Still have a radius of r. Don't need to show these two. So in theory, I could go that fast because that was all review for you. If it wasn't, take some time to stop, go back, take some good notes on this, and be prepared to ask questions in class. That's all I have for you now. Have a great day.